Hello, so I thought in this video I would explain what the basics of a shader are. And I know there's lots of tutorials and videos online, but I thought just the sort of challenge of trying to explain what a shader is as quickly as possible, but in a different way, so through an example. So what I've done is I've stripped down a shader to its almost minimal form, and then hopefully explain what a shader is using that. So here we have a cube on the screen, and it's just just being rendered as a red cube. And this is being rendered using a shader I've got here called basic shader. There's a material attached to the cube, and that material is using that shader. So if we open the shader up now and just have a look what's going on. So the shader runs on the graphics card and it's pretty much responsible for determining where the pixels are for the cube and what color they should be. And it's done in two parts. First part is determining where the pixels are, and the second part is determining their color. So if we start off by pointing out that this is a .shader file, and you can see there's a shader block here with the name of the shader, and just as I said, we're rendering this cube using a shader, but in actual fact there are two shaders in this file. The way Unity works is it bundles up shaders into a single file. So we've got a vertex shader and a fragment shader, and each one of them is represented by a single function. So we've got vertex and fragment. In fact, up here, this line here, pragma vertex vert and pragma fragment frag, is basically saying there's a vertex shader in this file and it's called vert, this one here. So this is telling it what the name is, and there's a fragment shader called frag. Now fragment shader is sometimes called pixel shader, and the reason for that is it determines the color of the pixels. So once the position of the pixels for the cube are determined, the pixel shader or fragment shader is called for every pixel of the cube on the screen, and this function determines what color it is. So this function is called with the coordinate of the pixel, and we're not using that here, and its responsibility is to return a color, and here we're just returning red, which is why all the pixels of this cube are coming out red. We could change this to blue, like this, so the blue component, and it's now gone blue, like that. I think the fragment shader is the most easy one to explain. The other one is the vertex shader, and this is run before the fragment shader. This is what helps determine where the pixels are on the screen. Now you don't actually specify where the pixels of the cube are. If we go to the 3D model, the actual model data, of course, is made up of triangles, and so the data isn't where every pixel is, it's just where all the corners are, or where all the vertices are. Now, when someone makes a model like this, I wonder who did make this Unity cube, but say like they're making a character, a 3D character for example, the positions are often relative to an origin. So on a 3D character, often the origin is the character's feet, for example. So these 3D points, of course, are going to be in something called model space or object space. So they're relative to an origin that belongs to that model. Now what we need is positions on the screen, because we need to know where the pixels are going to go. So what the vertex shader is primarily responsible for is to convert those 3D object space coordinates into screen coordinates. So it's basically asking where is this vertex on the screen. Now if you can work out where the vertex position is on the screen for 3 points of a triangle, the graphics card can then actually just fill in the space in between those points as a triangle of pixels, and that will be the triangle on the screen. So what this vertex shader is responsible for is income the positions, the 3D positions from the model and the model space, and what we've got to do is return the position in screen space, basically. Now you might be wondering why I've got these crazy words. This was just to try and highlight something, which is that you can call these fields whatever you want. Basically, it doesn't matter. It's this part afterwards, which they're called semantics, and they actually indicate the intent, what should be put in these fields, or what has been put in these fields. So the graphics card's so this is the data that comes in to our vertex shader for each vertex, and there's actually more than just position data stored in 3D models for each vertex. There's also like texture coordinates and normal data, for example. We can control here what data gets passed in, what data Unity will basically forward about the model. And in this case, we're saying put position information into this field. And it's a float 4, so it has like an X, Y, and a Z, and it also has actually a W. But in this, for the purposes of this, only the X, Y, and Z really matter. We're saying put the position data in there. So this vertex shader running on the graphics card is called for every vertex, and the information about the vertex, which we define here, is passed in. So the position data is passed in. What it has to pass out as part of the structure, which we also get to define, is the screen position. And so we're saying here's a field, and this is going to be screen position. So what we return out of here, the graphics card's basically going to go, oh, okay, this is the screen position, and then it's going to use that to build up a triangle of pixels on the screen, and for every one of those pixels it calls into the fragment shader for every one of those pixels, asking what the color is, asking us what the color. So it's almost like we're hooking into this kind of pipeline that's going on to determine things. What it means is we can modify the colors based on stuff, and we can also modify vertex positions based on stuff. Now this one's particularly complicated because of course the position of the vertex on the screen, as you can see here as we move around, it depends not only on where the camera is and which direction it's facing, but also it can change if the object is in a different position in the world or is rotated differently. So in order to convert the 3D position from model space into screen space, there's a helpful method that does this automatically, and this is automatically added if you create a new unlit shader. Unity automatically puts this in the vertex shader like this. It's Unity object to clip position. We can actually look at the source for this. This basically does the conversion based on camera location and orientation of the model and stuff like that. Like it says here, So that was a quick overview of what shaders are. Hopefully you found it interesting or useful. Perhaps you knew the information already. I've tried to keep it nice and short so it doesn't waste anyone's time either way. Thank you for watching though, and goodbye for now.